So in today's class, we will discuss Unit 4, that is random process now. So we'll be discussing Unit 4, that is random process. Till Unit 3, we have discussed about random variables, yes or no? So we have discussed just random variables. Now we are discussing random process. Okay. So what is random process? The random process is used to study the variation of random variables with respect to time. Okay. So if random variables are varied with respect to time, then this is called random process. Okay. So we know that the random variables are function of sample space. Okay. So we have discussed that what are the random variables? Random variables are nothing but the outcomes of the experiment. Okay. What is sample space? Sample space will have all possible outcomes. So the random variables are function of sample space. Okay. Now what is random process? The random process is function of both random variables and time. What is random variable? All random variables are available in the sample space S. Okay. So it is S comma T. Okay. So the random process is function of S comma T. Okay, that is sample space and time. What is S here? S is nothing but the sample space, whereas T is nothing but the time. Okay, and we also discussed what is stochastic process. Stochastic process is also nothing but the random process. Here also we are discussing what is the how the random variables are varying with respect to time. Stochastic process is a process that is introduced the concept of random process. Okay, what is the stochastic process deals with? It also deals with randomly varying time waveforms. Okay, so the stochastic process deals with randomly varying time waveform. Okay, time waveforms. Okay, so what are the examples here? The examples are the message signal, okay, voice signal, music, okay. So fluctuation of variation of temperature or variation of weather, all these are the examples of stochastic process. Okay. So here, because if you observe all the signals, message signal or voice signal, music signal, or variation of weathers, we don't know what is the origin of this, where these are originated. Okay, we don't know origin of this. So how do we characterize this? These are characterized by using statistical measurements. We use statistical measurements to describe these characteristics. Okay, so we have to use statistical measurements to describe these characteristics here. Okay, now what are the to obtain the statistical measurements? We'll be using probability density function and probability distribution function. These are the two statistical characteristics we use to obtain the behavior of this random process. Okay, probability probability density function and probability distribution function. These are the two functions we use to obtain the characteristics of random process. Okay, and since this random signals, we don't know where it has started. Okay, and this random signals or our random process is infinite energy signals. These are infinite energy signals. Okay, even though these are infinite energy signals, we use the statistical characteristics. Okay, here, what are the different statistical characteristics we use here is we we'll be using correlation and covariance. These are the two statistical characteristics, whereas correlation and covariance are, okay, these are finite energy characteristics. So using this finite energy characteristics, we can obtain what are the statistical characteristics of random signals. Okay. And just now we have discussed what are the examples. The examples are message signal, voice signal, music signal, noise, what is the noise generated outside, variation of weather, all these are the examples. Okay. So what is random process? Random process is nothing but if the random variables are varying with respect to time, then this is called random process. And random variables are function of sample space. No? Because what is random variable? The possible outcomes of an experiment is called random variable. So random variables are function of sample space. Now if we observe random process, what is random process? It is function of both random variable and time. If the random variable is varying with respect to time, then it is called random process. Okay. So how do you denote random process? Random process is function of sample space and time. Okay. And we also discussed that the random process is also called stochastic process. Okay. So we know that what is stochastic process? Stochastic process deals with randomly varying time waveforms. Okay, so the time waveforms are varying randomly. Then the how to deal this? We'll be dealing this by using stochastic process. Okay, so the examples: which are the waveforms varying randomly with respect to time? Which are the waveforms varying randomly with respect to time? Here are message signal, voice signal, music signal, noise, variation of weather, etc. Okay, these are the different types of signals. These signals are varying randomly with respect to time. Okay, so since these signals, we don't know where these signals are started, and we don't know the characteristics of these signals. Okay, to understand the characteristics of these signals, we have to apply statistical measurements to obtain the characteristics of these signals. Okay, what are the statistical measurements we can apply? We can apply probability density function, probability distribution function. These are the two statistical characteristics we apply to obtain the characteristics of random signals. Okay. And if you observe these signals are infinite energy signals. So the random process is having infinite energy signals. So here, what is here, we can also characterize this by finite energy functions. What are the finite energy functions? Correlation and covariance are finite energy functions. Using this, we can characterize this infinite energy signals. Okay. So this is the introduction of random process. Okay. Now we'll discuss random process definition. Okay. So the definition of random process here is, we have discussed that if the outcomes of the experiment is varying with respect to time, then it is called random process. What is random process? The outcomes of the experiment is varying with respect to time, then it is called random process. Okay. Now, so for example, our experiment is having the sample space x1, x2, so on, xn, there are xn. Okay. Now each outcome is varying with respect to time. Okay. And what is that we get? x1 of t, x2 of t, so on, xn of t. Okay. So this set is called random process. So it is denoted as capital X. Okay. So the random process is nothing but a family of, it is a family of functions. It is having family of functions, and we denote it as x less than or equal to x t comma s, where s belongs to capital S, whereas t belongs to capital T. Okay, so the random process is defined as, how do we define random process? Random process is defined as a family of functions, okay, where x less than or equal to x, t comma s, where s belongs to capital S, t belongs to capital T. Okay. Now here we have observed that what is random process? Random process is function of two variables, the sample space and time. Yes or no? See here, what is the x1, x2, so on, xn are nothing but the sample space and it is also function of time. So what is random process? Random process is function of sample space and time. Okay. Now, for example, you take an example of a number of calls received in the peak time. Okay, number of calls received in peak hours will be varying with respect to time. Okay, so what is the random process is total number of calls. Okay, number of calls received will be the sample space. How many number of calls we are receiving in the sample space, and it depends on time. So the sample space is varying with respect to time. Okay, so that is the example for the random process. Okay. Now, for example, just now we have discussed what is it. X is equal to x1 of t, x2 of t. That is each outcome of a sample space is varying with respect to time. Yes or no? X1 of t, x2 of t, so on, xn of t. Okay. So, for example, we have discussed that what is x1? x1 is the randomly varying time waveform. Okay, so it is varying randomly with respect to time. So this is called x1. So this is called x1 of t. Okay. Similarly, x2 of t is another time varying random waveform. So it is varying randomly like this. So this is your x2 of t. So on how many we have totally? Because our sample space is having n number of elements. So how many waveforms will be having totally here? N number of waveforms. So we have n number of waveforms like this. This is the nth waveform. So these are random signals. So draw the signals randomly. That's all. Okay. Now we discuss that we can obtain the random variables from the random process. Okay. So we can obtain what is that? Random variables from random process. So how do you obtain random variables from random process here? So for example, you fix time t1. So you will be fixing time t1. This is your time now. This is your time axis. We fix from time t1. Okay. Measure the signal value. Say it is x1. So what is here? Signal value is x1. Say the second signal value is x2. So on, this is xn. Okay. Now group all this. That is nothing but x1. x1 will be having the signal values at t is equal to t1. Similarly, to find out the value at t2. So to find out the value at t2, we fix the time t is equal to t2. Okay. Then what is this values here? Measure the signal values. If you group all the signal values, we will be getting the second waveform. Okay. So you observe this x1 of t, that is the first outcome is varying with respect to time. So this is called the sample function. What is this called? The sample function. The first outcome is varying with the time. All these are called sample function. This is also called ensemble member. What is this? These are the two names for this. It is also called sample function or ensemble member. Okay. So just now we have discussed that we can obtain the random variables from the random process. How do you get x1? How do you get x1? So we have discussed that what is capital X? Capital X is function of both sample space and time. It is function of both sample space and time. Okay. Now this fix the time t is equal to 1. Whereas we are varying the sample space. Okay. So this is called, how do you write this as? This can be written as x1 of t. This one is called x1 of t. Okay. So like this we will be getting all the values. So how do you write xi? Xi is xi of t. Okay. So it is xi of t. See here, which is constant, for example, sorry here, t is constant, okay, which is varying, s is varying. So it is x1 of s, sorry, here also it is xi of s. So like this we can obtain the random variables from random process. What is another procedure to obtain random variables from random process? What is the another procedure to obtain random variables from random process here? So what we have to do, what we have done here, we fix the time and varying the s value. Okay. Now what we do here, we fix the s value and vary the time. Fix s value and vary the time. Okay. Now what you get, since x value is fixed, it is function of what is variable here, t, no? T is variable. Okay. So it can be written as x is xi. Okay, xi is equal to xi of t. Okay, that is the sample space is fixed, whereas time is varying. Okay. So like that we will be getting. So what is here? This is called time functions. What is this equations are called? These equations are called time functions. Okay. So now we'll discuss what are the different types of random process. Okay, there are two types of random process. The first one is deterministic and non-deterministic random process. Okay, so what is deterministic random process? The deterministic random process is nothing but here. What is that we have discussed? We have sample functions. Sample. So what is that we have discussed? We have sample functions. Okay. So if the future value of sample function, if the future value of any sample function, you take any sample function can be predicted from its past values. Okay, then we say that it is deterministic. Okay, from past values, then it is called deterministic. Then what is non-deterministic? Non-deterministic is that, okay, the non-deterministic random process is that the future value of sample space, sample function, the future value of sample function cannot be predicted. Okay, you cannot predict the future value of sample function from its past values, then it is called non-deterministic random variable. Okay. So the random variables are of two types. Okay. Deterministic random variable, non-deterministic random variable. Deterministic random variable is that, okay, the future value of any sample function can be predicted from its past values. Non-deterministic random variable is that future values of sample function cannot be predicted from its past values. Then it is called non-deterministic random process. Okay. Now, if you know, just now we have discussed, we have two ways to obtain the random variables. Okay. So how do you obtain random variables? By fixing t1 time, we get one set of random variables. By fixing the sample space, we get another set of random variables. Okay. So if you have like this, if you fix the time t1, okay, what is that random variables we have? Time t is fixed, okay. Then what is the random variable? We'll be having here is, say x is having the random variables x1 of t, x2 of t, so on, xn of t at particular time t is equal to t. Okay. So now if you have random variables, now for example you have the probability density function. What is xk here? Xk is x of, so sample space where t is equal to t. We are fixing the time t is equal to tk. Where sample space is variable, time is fixed. Okay. So now, for example, you have the probability density function of Now what is xk is having the random variables, no? F xk of x is the probability density function of the random variable. Then what is the mean value? Mean of xk is given as, it is integral minus infinity to plus infinity xk f xk of x dx. This is the formula we use to find out the mean value. Okay. So what is this mean value is called? Statistical mean. What is this called? This u of xk is called statistical mean or ensemble average. Okay. So it is called statistical average or ensemble average. Okay. So, for example, now you have time functions. What is time function? Your sample space is fixed. Time is varying. So, these are called time functions. If you have time functions, now if you are finding the average of that, okay, how do you find out average? The average is given by A of xit. So you are finding average over time. So it is in 1 by t integral 0 to t xi of t. So what is this called? This is called the time average. What is this called? This is called time average. Okay. If you are finding the average of time function, then it is called time average. If you are finding the average of the random variable by fixing the time t, time is fixed, whereas the sample space is varying, then it is called what? It is called statistical average or ensemble average. Okay. So this is the definition of the random process.